in 1957, while the United States was aggressively carving the interstate system into the American heartland. Great Britain was suffering a slow industrial death. Its vital trade arteries were an insult to modern engineering. Winding, narrow carriage paths designed for horses, now paralyzed by 20-ton industrial lorries. But in the damp, overlooked county of Lancashire, a visionary named James Drake had already redrawn the map of the country. He just had to outmaneuver a reluctant government to build it. This is the untold story of how the British motorway was born, not from a central plan, but from a quiet, technical insurgency. To truly grasp the state of the British road network in the mid-1950s, one must look past the pastoral nostalgia of the English countryside and examine the cold, hard mathematics of industrial decay. For a nation that had birthed the Industrial Revolution and dominated world trade for a century, Britain, in 1958, was a logistical anachronism of the highest order, while the West German Autobahns were humming with the sound of a revitalized economy. And the United States was celebrating the Federal Aid Highway Act of 1956, a project Eisenhower viewed as essential for national defense. The United Kingdom did not possess a single mile of modern high-speed motorway. Its vital commerce was forced to navigate a labyrinth of roads that had changed little since the Roman occupation or the era of the stagecoach. These routes were narrow, structurally inadequate, and fundamentally ill-suited for the explosive growth of post-war vehicular traffic. The economic cost was staggering. A delivery of steel from the industrial north to the manufacturing hubs of the Midlands could take several days, trapped behind farm tractors, local buses, and horse-drawn carts on roads that were never designed for the internal combustion engine. The very concept of trunk roads in Britain was a misnomer. They were merely slightly wider versions of village lanes, punctuated by sharp 90-degree corners, steep gradients that caused heavy lorries to overheat, and the constant grinding friction of urban bottlenecks. By 1955, the vehicle density on British roads was the highest in the world, yet the infrastructure remained frozen in the Victorian era. The villain of this story was not a specific person, but an entrenched, institutionalized mindset. The crushing weight of the Whitehall bureaucracy, and a Ministry of Transport that was pure austerity and an almost pathological fear of the future. The government's official stance was that Britain was too broke to build for tomorrow, still reeling from the debt of World War II. But for the men who understood the mechanics of progress, the reality was that Britain was too broke not to build. The conflict was a classic battle between the visionary engineers on the front lines and the paper in London who viewed every mile of asphalt as a threat to the national treasury. The bureaucrats saw a road as a static expense, a cost to be managed and minimized. The engineers saw it as a dynamic machine, a vital tool for the survival of the nation's industrial soul. This tension created a period of dangerous stagnation that saw British industry struggling to compete on the global stage, hampered by a transport system that was essentially a 19th-century relic trying to function in a 20th-century world. Foremost among these visionaries was Sir James Drake. To an American observer, Drake might be compared to a regional director of a State Department of Transportation, but his influence was far more subversive and far-reaching than any simple administrative title could convey. As the county surveyor of Lancashire, Drake was a man of the North, uncompromising, technically brilliant, and deeply frustrated by the inertia of the capital. He knew that the A6, the primary route through his county, was a strangulated artery that was suffocating the industrial output of the region. He had been planning for a different world since 1949, when he produced the Lancashire Road Plan, a blueprint that envisioned a tiered network of high-capacity roads that avoided urban centers entirely. However, the Ministry of Transport viewed his plans as expensive fantasies, better suited for a science fiction novel than a budget meeting. Drake realized that he would never win the argument in a boardroom. He had to win it on the ground by creating a physical fact that could no longer be ignored by the politicians in London. Therefore, he shifted his strategy from national advocacy to local execution, playing a high-stakes game of bureaucratic chess. Instead of asking for a national network, he focused on a single, local solution: the Preston Bypass. It was a brilliant tactical maneuver. By framing it as a local bypass to relieve the unbearable congestion in the town of Preston, where traffic often backed up for miles, he secured the permissions and the initial funding he needed. But James Drake was not merely building a local bypass. He was secretly building a prototype for the future of the British Empire. The Preston Bypass was designed to a technical standard that the British public had never seen and could barely conceive. It was 2 miles of pure engineering ambition, featuring no property, new pedestrians, no cyclists, and, most crucially, no level crossings. This was the birth of the special road concept in Britain, where the right-of-way belonged exclusively to high-speed motor vehicles, a concept that required a complete rewrite of British transport law. The engineering challenges of the Preston Bypass were immense and required a level of precision that tested the limits of 1950s technology. The route had to traverse the difficult, rain-soaked terrain of the Ribble Valley, requiring the construction of massive embankments and specialized bridges. The Salisbury Bridge, a steel box girderstracker, and the Higher Walton Bridge, a multispan concrete viaduct, were technical marvels in their own right, designed to carry the weight of modern industrial loads over existing obstacles without impeding traffic flow. Drake's teams had to contend with the notoriously wet and unstable boulder clay soil of the north, a geological nightmare that required innovative drainage techniques that had never been tested at this scale in the United Kingdom. They were pioneering sub-base specifications using wet mix macadam, a departure from traditional, slower methods that was intended to speed up construction but would later lead to significant complications. This was engineering on the edge, a high-wire act performed in the mud of Lancashire. While Drake was securing the north, another titan of engineering was preparing to build the backbone of the country. Sir Owen Williams. If Drake was the strategist, Williams was the structural poet of the concrete age, a master of reinforced concrete who had already designed the landmark Empire Pool at Wembley. Williams brought a brutalist elegance and an uncompromising functionalism to the project. He was tasked with the design of the M1, the first major long-distance motorway that would eventually link London to the industrial heartlands of the Midlands. Williams understood that a motorway was not just a surface, it was a continuous structure, a single organism of transit. Every bridge, every viaduct, and every culvert had to be designed as part of a singular, high-performance system. He was a man who worked in the language of loads, stresses, and moments, and he had no patience for the aesthetic sensitivities of the London elite, who preferred stone-clad bridges to his raw, functional concrete. He famously argued that a bridge should look like what it was, a structure designed to carry weight rather than a piece of decorative garden furniture. The construction of these roads was a monumental undertaking that challenged every convention of the British construction industry. The M1 project, in particular, was a logistical blitzkrieg known as Operation Motorway, overseen by the Ministry of Transport, but driven by the technical brilliance of Williams and the massive labor force of firms like John Lang & Son. The project saw 72 miles of high-speed road completed in just 19 months. This involved the excavation of 11 million cubic yards of earth and the construction of 131 bridges, averaging one bridge every few days. By modern standards, where such a project would be mired in decades of environmental impact studies and public inquiries, this pace was nothing short of miraculous. It was a testament to a generation of men who were used to getting things done under the pressure of war, utilizing a massive fleet of scrapers, bullets, and specialized paving machines that had often been repurposed from airfield construction. On December 5, 1958, the Prime Minister, Harold Macmillan, officially opened the Preston Bypass. It was the dawn of the motorway age in Britain. For the first time, a British driver could experience the sensation of uninterrupted speed, free from the constraints of 30-mile-per-hour speed limits that applied to all other roads at the time. There were no traffic lights, no cyclists, no farm animals, just the open road. However, the victory was short. The visionary had been proven right about the need for the road, but nature was about to provide a villainous twist that almost derailed the entire program. Only 46 days after the grand opening, the experimental asphalt surface of the bypass failed spectacularly. A severe frost followed by a rapid, unseasonable thaw caused frost heave in the wet mix, leading to the road surface cracking and disintegrating into a series of dangerous potholes. The bypass had to be closed for emergency repairs. The critics in the press and the skeptics in Whitehall pounced, claiming that the motorway experiment was a dangerous, expensive failure and that the country should return to its traditional road-building methods. But James Drake did not flinch under the pressure of national scrutiny. He used the failure of the surface as a technical weapon in his ongoing war with the bureaucracy. He argued that the road had not failed because the concept was wrong, but because the government had refused to fund the necessary technical specifications for proper drainage and a more robust foundation. He proved that a high-speed road required a level of investment specifically in high-quality lin mix, concrete bases, and extensive subsurface drainage systems that the British state had previously been unwilling to provide. This technical postmortem was a turning point for the nation. Instead of scuttling the motorway program, the government was forced to accept Drake's more rigorous engineering standards. The failure at Preston actually paved the way for the structural success of the M1 and every motorway that followed, establishing a new gold standard for British civil engineering. By November 1959, when the first section of the M1 was open to the public, the transformation of the country was well underway. The M1 was a revelation to the British public. It was a road with no limits, as no national speed limit existed on motorways until 1965. It cut the travel time between London and the Midlands in half, revolutionizing the logistics of the nation and creating the first motorway services at Watford Gap, which became a cultural phenomenon in its own right. For the American observer, it might have looked like a single highway, but for the British economy, it was a total redesign of the transport network. It allowed for the rapid movement of goods and people on a scale that had been impossible since the peak of the railway era in the mid-1800s. The motorways were not just roads. They were the new high-speed arteries that would allow the United Kingdom to remain a competitive industrial power in the late 20th century. It is a common misconception, often reflected in simplified historical accounts, that this was the work of a single quiet engineer redrawing a map in isolation. The reality is far more complex and far more impressive. It was a collective effort involving specialized planning teams within the Ministry of Transport, local county surveyors who knew every inch of their territory, thousands of laborers who moved millions of tons of earth, and a handful of dedicated civil servants who were willing to risk their careers to bypass the bureaucratic status quo. They were redrawing the map of Britain not just in ink, but in concrete, bitumen, and steel. The motorways, they built the M1, the M6, of which the Preston Bypass is now a part, and the networks that followed changed the very geography of the country. Towns that were once isolated backwaters became logistical hubs. The north-south divide began to shift as the distances between the industrial heartlands and the capital were effectively compressed by the power of high-speed transit. The technical legacy of these men is visible in every bridge and interchange that defines the British motorway network today. Sir Owen Williams, for instance, developed a standardized family of bridge designs for the M1 that allowed for rapid construction while maintaining extreme structural integrity. His use of mass concrete and portal frame designs meant that bridges could be erected without the need for complex, time-consuming scaffolding that would obstruct the works. These were pragmatic, elegant solutions to the problem of building a national network at high speed. The Preston Bypass, that original 8.2-mile experiment, remains a vital, heavily traveled segment of the M6, one of the busiest and most important motorways in Europe. The visionaries won the long game, proving that infrastructure is the foundation upon which all economic growth and national identity is built. The redrawing of the map was a triumph of engineering over inertia. It was a moment when the United Kingdom decided that its future lay in speed, efficiency, and modern infrastructure rather than in the preservation of a crumbling, horse-drawn past. It was an era of slide rules, blueprints, and the raw power of heavy machinery, a time when men like James Drake and Owen Williams saw a systemic problem and engineered a radical, uncompromising way around it. Their legacy is the very fabric of modern Britain, a network of high-speed arteries that continue to pulse with the lifeblood of the nation's commerce. They did not just build roads, they built the foundation of the modern British state, ensuring that the country could move into the future at the speed of progress. To delve deeper into the mechanical heart of this revolution, we must look at the specific equipment that made it possible. In 1958, the British construction industry was undergoing its own internal combustion metamorphoses. The era of the navvy with a pick and shovel was being replaced by the age of the heavy plant operator. Massive Euclid S21 scrapers, capable of moving 25 cubic yards of earth in a single pass, were imported from the United States to tear through the British hillsides. These machines were the heavy bombers of the construction blitz, supported by fleets of Caterpillar D8 and D9 tractors. The sheer volume of fuel consumed and earth displaced was a spectacle that drew crowds of onlookers to the construction fences. As the British public watched their ancient landscape being reshaped in real time, the technical details of the Preston Bypass construction provide a fascinating window into the challenges of the era. The road featured dual two-lane carriageways, each 24 feet wide, with a 15-foot central reservation. This was a radical departure from the standard three-lane roads of the time, where the center lane was a suicide lane for overtaking in both directions. Drake's design eliminated this danger entirely. Furthermore, the curves of the bypass were designed with transition spirals, mathematical curves that allowed a driver to turn the steering wheel at a constant rate, maintaining stability at high speeds. These were the same principles used in railway engineering, applied for the first time to British roads on a massive scale. The gradients were kept to a maximum of 1 in 25, ensuring that even the most heavily laden industrial lorries could maintain their speed without the catastrophic overheating that plagued older routes. Sir Owen Williams, design for the M1, also introduced the concept of the hard shoulder. In the original design, these were often just narrow strips of gravel or grass, but they represented the first time British roads had designated space for vehicles in distress. This was a direct acknowledgement that high-speed travel placed new stresses on the mechanical components of cars and lorries, and that the road must provide a safety net for mechanical failure. Williams also pioneered the use of sightlines in his bridge designs, ensuring that drivers had maximum visibility when approaching curves or interchanges, a critical safety feature for a road with no speed limit. The bridges themselves were often built using a method called segmental construction, allowing for parts to be cast off-site and transported in, a precursor to modern prefabricated engineering. The logistics of Operation Motorway involved a fleet of over 3,500 pieces of heavy equipment, including massive Euclid scrapers and Caterpillar D8 tractors. The project consumed millions of tons of dry stone, gravel, and asphalt. For the first time in British civil engineering, helicopters were used to survey the route and coordinate the movement of supplies across the vast, muddy construction site. This was a high-tech operation that signaled the end of the pick-and-shovel era of road building. It was the moment when British engineering moved into the age of the machine. The project was so vast that it required its own dedicated telecommunications network just to keep the various construction sectors in sync. As the network expanded throughout the 1960s and 70s, the quiet redrawing continued. The M6 was extended north to the Scottish border, and the M1 was pushed further into Yorkshire. The Spaghetti Junction in Birmingham became a global symbol of the complexity and ambition of the British motorway system. But all of these later achievements can be traced back to the stubbornness of James Drake in Lancashire and the structural brilliance of Owen Williams on the M1. They were the men who broke the deadlock and proved that Great Britain could, and should, build for the future. They were fighting not just against gravity and mud, but against a political culture that was addicted to the safety of the past. The story of the British motorway is also a story of the death of the steam age. As the motorways expanded, the heavy freight that had once been the exclusive domain of the steam locomotive began to move onto the roads. The efficiency of the diesel lorry, combined with the speed of the motorway, signaled the end of the railway's dominance. This shift was a fundamental part of the redrawing of the map. As the country's economic center of gravity moved from the railside factories to the new industrial parks situated near motorway junctions, the quiet redrawing was, in fact, an economic revolution that paved the way for the just-in-time logistics that define the modern world. Furthermore, we must consider the human element of this engineering saga. The thousands of men who worked on these projects, referred to as the motorway navvies, lived in temporary camps that resembled small cities. They worked around the clock, in rain and snow, driven by bonuses and the sheer momentum of the project. Their toil in the trenches of the M1 and the Preston Bypass created the physical reality of the vision. Without their labor, the blueprints of Williams and Drake would have remained merely ink on paper. The motorway camps had their own kitchens, cinemas, and medical facilities, creating a unique subculture of men who moved from one major infrastructure project to the next. As we look back on 1958, from the perspective of the 21st century, the achievement of Drake and Williams becomes even more significant. They were building for a world they could only imagine. They designed bridges and foundations to support loads that have since doubled and tripled, and yet many of those original structures remain in service today, a silent testament to the integrity of their calculations. The Preston Bypass, that original 8.2-mile experiment, is now a vital segment of the M6, one of the busiest motorways in Europe. The visionaries won the long game. The redrawing of the map was a triumph of engineering over inertia. It was a moment when the United Kingdom decided that its future lay in speed, efficiency, and modern infrastructure rather than in the preservation of a crumbling past. It was an era of slide rules, blueprints, and the raw power of heavy machinery, a time when men like James Drake and Owen Williams saw a problem and simply engineered a way around it. Their legacy is the very fabric of modern Britain, a network of high-speed arteries that continue to pulse with the lifeblood of the nation's commerce. They did not just build roads, they built the foundation of the modern British state. For the man who appreciates the mechanics of a well-built machine, or the integrity of a perfectly poured concrete span, the story of 1958 is a reminder that progress is never a straight line. It is a series of conflicts, failures, and hard-won victories. It is the story of how a few determined engineers quietly redrew the map of a country that was too afraid to do it for itself. And in doing so, they ensured that Great Britain would not be left behind in the rearview mirror of history. This redesign of the transport network did more than just reduce travel times. It fundamentally altered the socio-economic landscape of the British Isles. Before 1958, the country was a collection of isolated regions, each separated by the sheer difficulty of travel. After the motorways, the country became a singular, integrated economic unit. The visionary engineers of the 1950s did not just move dirt, they moved the very soul of the nation into the modern age. And they did it with the quiet, uncompromising competence that defines the greatest achievements of the engineering profession. The map of Britain today is a direct descendant of the sketches made by James Drake in his 1949 plan and the structural calculations performed by Owen Williams in the mid-1950s. Every time a driver merges onto the M1 or navigates the curves of the M6, they are participating in a legacy of technical excellence that began with a small, experimental bypass in Lancashire. It is a legacy of men who saw the future and had the courage to build it, 1 mile at a time, against the grain of their era. This was the moment the British motorway age dawned, and it remains one of the most significant and influential engineering transformations in the history of the United Kingdom. The technical complexity of the M1's overpasses alone deserves a chapter in the history of structural mechanics. Sir Owen Williams utilized a standardized bridge concept that was revolutionary for its time. Rather than designing 131 unique structures, he created a set of modular designs that could be adapted to different spans and angles. This included the 4-span open bridge and the 2-span portal frame bridge. By using a consistent visual and structural language, he not only saved time in the design phase, but also allowed construction teams to become experts in a specific set of techniques, increasing efficiency as they moved down the route. The sheer volume of material moved for the M1 is almost impossible to visualize. Imagine a wall of earth 3 feet high and 3 feet wide that circles the entire globe. That is roughly the volume of soil displaced to level the route for the first 72 miles of the motorway. To Manachetes, the engineers used mass haul diagrams, complex charts that calculated the most efficient way to move earth from areas where it was being cut to areas where it was needed for fill, minimizing the distance the heavy scrapers had to travel. TEAS was data-driven construction decades before the digital age. Furthermore, the environmental impact, though less scrutinized than today, was managed with surprising foresight. The engineers used balancing ponds to manage the sudden runoff of rainwater from the massive paved surfaces, preventing the flooding of local farmland. They also began the first large-scale roadside planting programs, intended both to stabilize the embankments and to screen the road from nearby villages, a practice that has led to the motorway. Corridors becoming some of the most important wildlife havens in the country today. The redrawing of the map was not just about the lines of the roads themselves, but about the motorway culture that followed. The introduction of the first service stations, like Newport Pagnell and Watford Gap, provided a new kind of social space, a plastic-clad version of the future where the British public could experience the novelty of fast food while watching the traffic rush past. For a generation that grew up with rationing and coal fires, the motorway was a tangible piece of the 21st century arriving ahead of schedule. In conclusion, the events of 1958 and 1959 represent more than just a construction project. They represent a fundamental shift in the British national identity. It was the moment the country stopped being a maritime power, looking outward across the oceans, and started being a modern, land-based industrial state, looking inward at its own potential. James Drake and Sir Owen Williams were the men who built the stage for that transformation. They were the architects of a new Britain, and their work remains the most important piece of infrastructure in the country. The quiet redrawing was the loudest revolution in British history, and its echoes are still heard every time a diesel engine roars to life on the M6.